Welcome to day 2 and module lesson 5, lesson 3 here. We are going to take a look at this first open exercise. It's just an easy construction. We're trying to find the center of a circle. Okay, so normally what we're looking for here is called the circumcenter. All right, which would be if we labeled 3 points on our circle, find the perpendicular bisectors. Remember the PBC, peanut butter and cheese, makes the circumcenter. However, we now know a different way, which is that I can just pick any 2 points on the circle, okay? You guys remember, here's my 2 points, okay? And then I'm going to pick 2 other points, making 2 chords. And if I were to draw the perpendicular bisectors, they have to be the diameters, and where the diameters meet makes the center. So we're going to take our compass, right? We're essentially going to just draw 2 circles here and here. All right, and then we can come down this way and draw 2 more circles. We'll change the color here. All right. And you can see these guys aren't going to meet here, but now it's pretty close to meeting where the actual, all the circles are meeting, which is kind of cool. But you have to make sure you draw the perpendicular bisectors and they can finish this construction. So take our intersections here. We draw the perpendicular bisector this way, draw it that way, and this intersection here is the location of our center. All right, so there's the construction we would essentially use for the first question. We are not going to do this next question. We are not going to do the kite. You're not responsible for knowing for that for the exam, okay? We are going to talk about question 3 here, okay? And we're going to go back to our note sheet, and we're going to talk about 2 angles. Well, one type of angle. The type of angle we'll talk about today is an inscribed angle, okay? In an inscribed angle, remember, the vertex is located on the circle, and it's totally inside the circle. So the angle itself, right, is inside the circle, all right? Kind of like a Pac-Man type thing here. And this is referred to as the intercepted arc. Remember what we said. If this is x, okay, the angle is equal to half of that, all right? Sorry, half of the arc. So this would be 1/2 x. So if this is 50, this angle would be a 25-degree angle, all right? That's the main concept for today. Now, the second one is on the way back of the sheet on the bottom, and it's this one. That if we have a quadrilateral that's inscribed, means it's all the way inside a circle, vertices on the circle, all right, that the opposite angles have to add to 180 degrees. And here is why. Angle A creates this intercepted arc from D through C to B, and angle C, right, creates this intercepted arc that goes from B through A to D. So these 2 arcs make up the entire circle, which is essentially 360 degrees, and these angles are always half of that. So if we said that this is 200 for this angle, or sorry, this arc, that leaves 160 for this arc, then we would guarantee to know this angle is 100, right, and this angle is 80, and these have to make 180. So the same thing's going to happen for B and D. So as long as you have the quadrilateral inscribed in the circle, opposite angles have to add 180. Keep in mind from yesterday, we know that if we have a circle, a triangle inscribed to a semicircle here, okay, that this angle has to be 90 degrees. So if one of the sides of the triangle is a diameter, 90-degree angle, chords, right, that are equidistant from the center are equal. And we talked about the fact that the diameter bisects the chord and is perpendicular to it. And I don't know if that's on here. So we're going to be doing that again today, okay? So we know in this triangle that if this is a rectangle, the joys of having kids, guys, that if this is a rectangle, these opposite angles have to add to 90 degrees. So that would be our rectangle. But, hi, Kate. Okay, I need you to go so I can finish, okay? I'll call you back when I'm done. You can say hi. All right. So we're skipping over. We're going over to page 4. All right. Just a quick conversation here about number 5, and then we'll get into a couple questions. So in number 5, if we were to draw the perpendicular bisectors of AB and AC, right? If I were to locate the midpoint, hold on, gotta fix something. If this is the perpendicular bisector, then when this cuts through, okay, well, it's definitely not located at the perpendicular bisector here, but if this cuts through, and we do the same thing over here, right? And this cuts through, they are essentially going to meet at the center of the circle, which is going to be the middle of line BC, okay? Perpendicular bisectors form the circumcenter. All right, so hopping on over to page 20, and here we get into some questions, all right? So number 3, in figure BCDE, if it's a rectangle, and DE is 8 and BE is 12, find AE. So if this is 8, right, BE is 12, that means that these two sides are also 8 and 12. And if I want to find the length of AE, what I'm actually going to do is draw the whole line, okay? And that means this is a 90-degree angle inscribed in a semicircle, okay? All right, and then we're just going to use Pythagorean theorem. So a squared plus b squared is equal to c squared here. 8 squared plus 12 squared is equal to c squared. And then we can do the math from here. So 8 squared, 64 plus 144 is going to be 208. And then we're going to take the square root from here. Now, this is a decimal, so this is not going to work. Now, what we're going to do is we're going to work on actually simplifying this radical. So let's work on that real quick. So if you remember, to simplify a radical, we're just going to take either a calculator and do factor, but if we don't have one, we can just use a factor tree. So if we divide this by 2, we're going to get 104. If we divide this by 2, we're going to get 52. Cut that in half, we're going to get 26. And cut that in half, we're going to get 2 and 13. So there's 1, 2, 1, 2, 3, 4 2s, and a 13. So we put our 4 2s inside, and a 13. And then we just have to circle our sets, square root, so it's doubles. Remember, from each set, we take out one number. So there's a 2 and a 2 out front, which gives us 4. There's a 13 left inside, and that's the length of C. All right. In number 4, same type of question. All right. Well, not exactly the same type. But we're looking to remember, wherever possible, to use radii to help us out here. Okay. So BC and CD are both 8. So this is 8. This is 8. Okay. And AD is 13. We're trying to find the radius of a circle. Now, 2 things. Number 1, this is a chord from B to C. So I'm going to move that first 8 out of the way a little bit because I'm about to do something to it. So this whole thing is 8. This is 8. And this is 13. So if we know that this is our 8, that if I draw my diameter, I know that it's going to be perpendicular and cut this chord in half. All right. So far, so good, right? Okay. Now, here's the other important thing. This now gets cut in half. So this is 4, and this is 13. All right. We want to find the radius. So we're going to know that we need to figure out this right here first. Okay. So we can use our right triangle here, right? This whole thing is 12 and 13. And then once I get that, I can draw, I'm going to switch colors here. I can draw this triangle, right? 4 and whatever x is, and I'll be able to get, we'll call that y. Okay? So starting with the first triangle over here in red, I sides of 12 and 13. Remember, 13 is the hypotenuse. Okay? So we're going to do 13 squared minus 12 squared. is equal to x squared. All right, this is 169 minus 144. This is 25. And then we know that the square root of that is going to give us 5. All right, so we have sides of 5 and 4 now. So to get y, we're going to do Pythagorean theorem again. Remember, y is the hypotenuse. So it's y squared equals, not plus, and then 5 squared plus 4 squared. Let's go simplest radical form again here. So y squared is 25 plus 16, which is going to be 1141. And I don't believe that actually breaks down. I believe that is prime. All right, and y is equal to the square root of 41. All right, okay. On to the next page. We got another one at number 5. So another question similar to yesterday. All right, BF and BG are parallel chords. So we just know they're parallel. We don't know how far apart they are. Well, we know they're 14 altogether. So the length to get from there to there is 14. But I don't know, this is important, I don't know that these are equal, which would be super helpful, okay? Since they're not equal, we know that these two chords aren't congruent. All right, now DF, which is this line, all right, is 12. And AB, which is our radius, important, right, is 10. We want to find the length of BG, which is that line all the way down there. We want to get this, okay? Now, we know that EH and BG are perpendicular, so we know that this is going to get cut in half, which is important. And these lines are parallel, which means this is also going to be perpendicular, and this gets cut in half, so that's also helpful because this has to be 6. All right? Now remember, draw a radius wherever possible. That's the radius we want. So now I get a right triangle. We know that this the radius is 10. So can we figure out the length of EA here? Because if we know EA, then we can get AH, right? Because the whole thing's 14. And then I'll be able to find BH, we'll call it Y, and that'll let me get the whole thing of BG. So pause it, see if you can do it. Okay, see if you can do it first. Then hit play. All right, do your thing. No, really, you're supposed to pause it. Okay, so same thing here. So if you started off, hopefully you did 10 squared, right? Minus 6 squared is equal to x squared. This is going to equal 64. And then the square root of that is going to be 8. So if this part up top is 8, that makes this part on the bottom 6. And so we do the opposite thing we just did, where we have the 10 squared minus 6 squared, right? And this is 64, which we get 8, remember? And so if this is 8, so is this, and that means that BG has to equal 16. All right. On the last page here, we don't have anything because I went too far. And that's it for today, guys. Remember, check the Nearpod lesson out. The big thing for today, remember, is questions similar to this. Draw that line when you can, and also remember the opposite angles in a parallelogram that's inscribed in the circle are always 180. We didn't get to a lot of that today, but as long as I draw a 4-sided figure here, okay, and I tell you, for instance, that this arc right here, let's say is 200, you should be able to give me that angle, okay? Number 1, this angle over here, remember, is inscribed to this arc, so it's always half, and these two angles have to add 180, and so that's how we would end up getting that this angle is 80 degrees, okay? So just remember, as you guys are working along, that's the important thing for today as well, okay? That's it for today, guys. Checking out. Have a good day, and we'll see you tomorrow.